Hello guys! I'm Joseph Gonzaga.
And I'm Maylin M. Sagadan.
And I'm Chaz Engalia, and now we are going to talk about free fall motion.
So first, what is free fall motion? Free fall motion is the motion of an object that is being acted upon solely by gravity. So in this case, we will drop something or something that is falling from the sky.
So before we explain the concept of acceleration due to gravity and provide the formulas and equation needed to solve each free fall motion, let's give you information. V0y or initial velocity is a velocity of the object before acceleration. Vy or final velocity is a velocity of a given object after a period time.
And G stands for gravity, which is 9.8 meter per second squared, and it is constant. Gravity is a force that tries to pull two objects towards each other. And time is its measure in which event can be ordered, while the acceleration in which 0 meter per second, and it is constant. It is the rate of change of velocity per unit of time. Air resistance. Air resistance describes the forces that in opposition to the relative motion of an object as it passes through the air. So for example, let's say if you hold two balls in the air, a 10-gram ball and a 5-gram ball, and you hold it 5 feet above the ground in the same height. Once you release it from rest, both balls will be in free fall. Which ball will reach the ground first? It is the 10-gram ball or the 5-gram ball. So both objects will reach the ground at the same time. The reason for that is they place in the same height, and that under the influence of same gravity. The acceleration due to gravity is 9.8 meter per second squared, but because everything is the same, the height is the same, if you take away air resistance, both objects will hit the ground. Now let's say if we use an action demonstration of stone versus a flat piece of paper. So the stone is a lot more heavier than the piece of paper. Let's say it's a 1 kilogram stone. So now with air resistance, which one will reach the ground first? The stone will going to straight down. The paper might go this way, that way until it will reach the ground because of air resistance. What's gonna happen if you take the same stone and the same paper but you crumpled it into smaller pieces? Now the effect of air resistance on this paper will be greatly reduced if you crumple the paper tightly. And now you let it go. These two will hit the ground approximately about the same time. The greater the surface area of the paper, the greater the effect of air resistance. Air resistance increases in surface air, so once you crumple the paper and then you drop it, you'll see that it's about the same time when they reach the ground with the stone. Air resistance is greatly reduced, so if you can eliminate air resistance completely, so both objects should reach the ground exact same times because they are under the influence of the same gravity. Now before we go over a few free fall problems, let us talk about the equation that we need to solve it. So whenever an object moving with constant speed, this is the equation that we need to use. D equals Vt. D can be used as distance or displacement. Just remember, distance is a scalar quantity and this displacement is vector quantity. So displacement can be negative or positive, but distance is always positive. So anytime an object is moving with constant speed, you can use this equation. Now, when an object is moving with constant acceleration, you can use any one of these four equations. Vf equals V naught plus AT. Vf represents the final velocity or speed. V naught is the initial velocity or speed. A stands for acceleration, time stands for t. Just remember that velocity is speed with direction speed is scalar quantity. It be only positive. Velocity can be negative or positive dependent on what direction you're going. So for the object that's moving from the right, the velocity is positive. And if the object moves from the left, the velocity is negative. The in free fall situation will deal with motion in y direction. When the object goes up, the velocity is positive. When the object goes down, the velocity is negative. The next formula that you need to know is V equals V naught plus T 1/2 AT squared. And D equals 1/2 times V naught plus V final times T. And V final squared equals V naught squared plus 2AD. And VF equals V naught plus AT. You can use this 4 equation when it's moving in a constant acceleration. You can use only when an object moving in constant speed is the equation D equals VT.
So our problem number 1. A ball is dropped from the rest on a cliff. Our first problem, what is the speed of the ball 5 seconds later? So, as it falls down, we don't know if it hit the ground at this point. We just want to find the speed 5 seconds later. So, it is important to make a list of what you have and what the variable that you needed to find what is the initial speed of the ball. On this problem, notice that the ball dropped from the rest to the initial speed is 0 meter per second. So our goal is to find the final speed. Now we know the time is 5 seconds. Now the time is 5 seconds and the acceleration due to gravity is negative 9.8 meter per second squared. So the formula that we're going to use is final velocity is equals to V naught plus AT. So as we know that our V naught is 0, so we're not going to use it. Then V naught, to get the final velocity, we need to multiply the acceleration, which is negative 9.8 due to gravity, and time, which is 5 seconds. Then multiply the negative 9.8 meter per second times 5. It will give us the answer of negative 49 meter per second. So now let's go back to the question, what is the speed of the ball after 5 seconds? The answer for speed is positive 49 meter per second. Because speed cannot be negative, that's why we make it positive, and this is the answer in part A. And for the part B, what is the velocity of the ball at this time? The velocity is negative 49 meter per second because the ball is moving in the negative y direction. That's why velocity is negative. Remember, velocity is a vector quantity, speed is scalar. For part C, how far does it travel during this time? And what equation that can help us? D is equals to V naught T plus 1/2 AT squared. And since we have already initial speed and we know that time, we have also the acceleration, so it is enough for us to solve the problem using this equation. D is equals to V naught T plus 1/2 AT squared. Since our V naught is 0, we're going to cancel it, and we have just substitute the A, which is negative 9.8 meter per second squared, and time, which is 5 seconds. Just multiply the two variables and it will give us the answer of negative 122.5 meter. So the answer represents not the distance traveled but It is the displacement. And this is the answer for the part D. Remember, displacement is a vector like velocity, and it can be negative or positive because the object moves in a negative y direction and the displacement is negative, but the answer in part C.
So the answer represents not the distance traveled, but rather it is the displacement. This is the answer for part D. Remember, displacement is a vector like velocity. It could be negative or positive because the object moves in a negative y direction. But the answer in part C is simply positive 122.5 meter. Whenever an object moves in one direction, it is moved straight. The distance and displacement, they have the same value and the same magnitude, but the sign may be different dependent what direction is going.